All right, so let's move on to our next page. We're going to talk a little bit more about our measures of center, get into some of the nitty-gritty so we're ready for the multiple choice portion of our tests. And then we'll move on to measures of spread. We're going to finish out SOX today. Yeah. So the median is a resistant statistic. Specifically, it is resistant to outliers. This means that it is not heavily influenced by the presence of outliers or skewness. We're going to go back to some examples from yesterday and take a look at what this looks like in a minute. But the median is resistant. The mean, on the other hand, is not resistant. The mean is heavily influenced by outliers. And we saw in one of our data sets yesterday, we had mostly large values, 5 to 10. We had one of those small values down at 1, and that tiny value at 1 was pulling the mean down lower than it should have been, because the mean is very susceptible to influence by outliers. And we're going to look back at our mean and median examples yesterday to see what that looks like. Yeah. Wait just a second, because I see some pencils moving. Okay, so back a page. I'm going all the way up to our median calculations, example A. And you can see for example A, when we were calculating the median, we sorted the data from smallest to largest to find the median. What happens if instead of having 10 in this data set, I had 100? Does that change the median? I see several people shaking their head no, and you would be correct, because the way we find the median is crossing pairwise values off till we get to the middle location. It has nothing to do with what's sitting in those positions, just where is the middle position. Whatever happens to be sitting there is your median. So as long as the numbers on this side are still greater than 8 or equal to 8, as long as the values on this side are less than or equal to 8, 8's going to stay in the middle, because it has to do with location. If I take that same data set and I go look at our mean calculation, and I make that same replacement, I make 10, 100, what does that do to our mean? So everybody should have their calculator out. I'm going to give you just a few seconds. Rerun that mean calculation with 100 instead of 10. What is that going to do to our mean? Yes, I'm eating my lunch. Don't judge me. I had a club meeting today. All right, who's got a value for me? Yeah. Yeah, it goes up to 16.8 with that replacement, more than double what it was before. That outlier had a really strong pull on the mean, did nothing to the median. That's what we mean by the median being resistant and the mean not being resistant. Yeah? We're going to talk about measures of spread in a minute, and we're going to match the measures of spread to the measures of center. So non-resistant stat with non-resistant stat, resistant stat with resistant stat. Yeah, good. So back here, we're going to choose our measure of center based on the shape of our graph. It's why when we do SOX, it's shape and outliers first. They determine center and spread. So if my shape is nice and symmetric, doesn't have to be perfect, approximately symmetric, and I don't have any noticeable outliers, I'm going to use the mean. The mean is the default. That is what statisticians prefer because it accounts for every data value. For symmetric data, it is nice and pretty. Yeah. If, when I do SOX and I do my shape and my outliers, my graph is heavily skewed, my peak is like way, way off to the left, got a really long tail to the right. I have noticeable visual outliers. Most of my data is here. I've got one blurb way, way out here by itself. In those cases, I should use the median, sorry. If there's no outliers, there's no heavy skewness, I can use the mean, there's no problem. But the second there's outliers or noticeable skew, I want to use the resistant statistic instead. The resistant statistic will be a more accurate measure of the middle of the data in those cases. Yeah. Okay. So we're going to compare really quick where the mean and median sit for different shapes of graphs, because that is a popular question on the multiple choice portion of your test. And then we'll move on. So for all of these, we're comparing the mean to the median. Mean and median. Mean and median. Mean and median. The question is, how do they relate? How do they relate? So for the first line, it says in symmetric distributions. So for example, our normal distribution, which looks like a bell-shaped curve with its peak in the middle. Most of my data is here, short tails on either side. My mean and my median should be approximately equal. For nice, pretty symmetric graphs, all of those measures of center should be stacked almost right on top of each other. And we saw that yesterday when we did our calculations for data sets A and B. One of them did have the mean and median right on top of each other, 5.4 and 5.5. That's how we knew it was likely symmetric. Symmetric graphs, measures of center are all the same. If our graph is left skewed, the mean is to the left of the median. On a number line, if you are to the left, are you a smaller number or a bigger number? Smaller. The mean is smaller than the median. Notice when I write it this way, the arrow points to the left. It follows the direction of skewness. We like that. If my data is right skewed, that means my mean is to the right of the median. Is the right side of the number line bigger numbers or smaller numbers? Bigger numbers, so the mean is bigger than the median. Alligator eats the bigger number. Notice that it's pointing to the right now, matches the direction of skew. Yeah. The direction of skew is telling us where the mean is relative to the median or relative to the peak. The median should track the peak pretty closely. If my peak is on the left, my median should be on the left side. My peak is on the right, the median should be on the left side. The skewness is tracking where the mean goes relative to that. Okay. Questions on our measure of center before we move on to measures of spread? No, okay. We're rounding out socks. For our spread or our variability, there's 3 measures, 3 of them. We're going to use 2. One that's going to pair up with a mean, one that's going to pair up with a median. This first guy, doesn't pair up with any of them, but he's quick to calculate, and so sometimes he's a good starting place if you're doing fast calculations. The range does not mean what it meant in Math 3. In statistics, the range is looking at the width of your data. And we calculate it by doing the largest data point, our maximum, minus our smallest data point, our minimum. Max minus min. Max minus min. That is not an interval statement. That is not 5, 2, 3. I wouldn't write it out in words that way. It is a single number. You need to evaluate the subtraction and give me a single digit answer, yeah? Single number answer. Nine times out of 10, when we mess up this calculation, it's because you gave me the min and the max separated by a comma like you were still in Math 3. And while technically that does accurately describe the width of the data, it's not the statistical range. Statistical range you have to subtract. Give me a single answer, yeah? Okay, we're going to do it really quick. For the same sample data we used yesterday. Data set A, where is my min? 1. I'm glad somebody has their voice today. Very good. Where is my max? 10. Very good. So my range, R, should be 10 minus 1, which is 9. Happy face. Fast. Yeah? Super fast. We like fast calculations. Good. Second one. Where is my min for B? 1. Where is my max for B? 10. My range is identical. Frowny face, we already know that those distributions are not identical. One is symmetric, one is skewed. So the range by itself gives us a little information about how wide I need my graphs to be, but that's about it. Because we already know those distributions look different in terms of their shape. Quick question for you. I'm going to give you a couple seconds to talk in your group. Is the range a resistant statistic? Discuss. I'm going to give you like 90 seconds. You can talk to each other. All right, we're going to vote with our thumbs. If you think it is resistant, you're going to give me a thumbs up. If you think it is not resistant, you're going to give me a thumbs down. Please show me your thumbs. You see down, 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 up and down, up and down, sideways, up, some confusion, up, down. Okay, so it looks like if we were voting down would win, but there's some uncertainty. So this half of the room was pretty much universally down. Can somebody tell me why you said not resistant? Yes, Drew.
I said not resistance because it's max minus min. If there's an outlier all the way to the left or right, it's going to heavily change how the value comes out.
Very good. Outliers tend to be one of those two values, a max or a min. So if an outlier is sitting there, heavy influence on the range. Very good. I know how to spell, I promise. Okay, questions about the range? No, we feel good about the range. Good. And now I'm going to apologize because we're about to switch gears to the opposite end of the spectrum, to something that's a little gross. And you're going to see the formula and you're going to groan. You will never have to calculate what we're about to discuss by hand. Your calculator will do it for you. I'm going to show you what it looks like done by hand because it is a doable process, but you will be using this all school year for it, yeah? But it's important we see the formula so on the multiple choice questions, we can answer questions about the structure, about how it behaves. So our first measure of spread is the standard deviation. Most of you probably saw this in Math 3, presented by a non-statistician. Now you are getting the presentation from a statistician. So let's get into the nitty-gritty. The standard deviation is a measure of the average distance from the mean. Average distance from the mean. Why is your pencil not running? Stop staring at the girls and write your notes, please. Do not get paid enough for this. You will notice average is in quotations because this is not a literal average in quite the same way that we usually evaluate it. But it is an averaging process. We're going to look at what that looks like. We're going to start with the equations, yeah, and then we'll do some practice. Just like last time, we have different notation for samples and populations. So I'm going to separate the equation into two pieces, sample, population. All right, so first, symbols. Just like last time, English letters for sample, Greek letters for population. What English letter makes sense for standard deviation? S. Exactly what we're going to use. On your calculator, you will see an S followed by an X to indicate that it is the standard deviation of a bunch of X values. We're going to use the Greek equivalent for the population, which is the lowercase sigma. I know. This is the third time I've watched the giggles every time I say that letter. I'm going to have to say it a lot because we're going to be looking at population standard deviation quite a bit. So SX for sample, sigma for population. And we're calculating an average. How do we calculate an average or a mean? There's two things we do. What do we do first? Add all the values. I got it in multiple places. Perfect. I know the shorthand notation for a long sum is that weird Greek letter. And in this case, I am adding up the distance from the mean for all of my data values. That's what I'm taking the average of. So to write that, I'm going to do x minus x bar for my sample. Data value minus mean. That should be how far apart they are. What is that going to look like for my population? Something minus something. Does the symbol for data value change? Data value is a data value. What about the symbol for the mean? Yeah, that thing that looks like a wonky M, the Greek letter mu, yeah. It's still data value minus mean. Symbol changes. Note cards, yeah, flashcards. Make your flashcards. Good. After we do that, we're going to run into a problem. When I calculate data value minus the mean, if my data value is smaller than the mean, will that be positive or negative? Negative. Data value x is smaller than x bar. Negative answer. So some of my answers are over here. If my data value is bigger than the mean, positive or negative? Positive over here. So some of my differences are over here. Some of my differences are over here. If I add all of them together, where do you think I'm going to end up? In the middle at 0. Yeah, the mean cuts that data in such a way that there is an equal weighting of data points below and above. So if I add all those things together, I end up with 0. That's not helpful, because if they add up to 0, my average is 0. In order to deal with that sign cancellation, I'm going to make everything positive by squaring that difference. Because I know a negative number times itself turns positive. So then I'm adding a whole bunch of positive numbers. At some point, I'm going to have to undo that square with a square root. But we'll worry about that later. Okay, so we've got our sum. That's the first step in finding an average or a mean. What's the second step? Divide by the amount of data. And for the population, you are exactly right. We divide by the population size, capital N. For the sample, there is a slight tweak. If we are calculating the sample standard deviation, we divide by n minus 1. The AP board will never ask you why. They just expect you know that. Later today, I will post a short little article with an explanation on why that is, if you are curious. Yeah. If you are not curious, it's not on the test. But there is a mathematical reason for it. We don't just do it for funsies. Some of it has to do with the fact that if we're dealing with a sample, we're likely underestimating the variation, and so we're kind of compensating for it here. Good. So I've calculated my average. I have to undo the squaring. How do I undo squares? Square root. Where is square root, that whole thing? Square root. Square root. All right. So a warning. At no point in this course should you ever be calculating the population value. They are never going to ask you to calculate the population standard deviation. It doesn't happen. In the same way that we very rarely have the population mean. Interviewing an entire population is time-consuming and expensive, yeah? So when you are pulling data from your calculator and you are asked for a standard deviation, it's this guy that you want to pull from the calculator. Your calculator will give you both, because the calculator is not smart enough to know whether you gave it population or sample data. Calculator's dumb, yeah? So it's your job as a statistician to know which one you want. You want the sample value. You want SX, not sigma. Sigma is bad. Okay, so when you're doing this calculation, you're going to do what we did for the mean and median. Shove the data in a list, run one var stats. We're going to practice. Yeah. If you are a masochist who likes to do tedious math calculations and you want to do this by hand, make a table. Do not try and do this willy-nilly on a calculator without any structure. It will be a nightmare. You would make 3 columns, one for your data values, one for the difference between your data values and the means. If my pen would work. Sometimes I hate this TV. Come on. There we go. And then one for that difference squared. Doing those calculations in succession is easier. Your last steps are going to involve adding down that last column and then dividing and square rooting. It's easier to do that sum when you've broken the calculations down into steps and you do it one at a time for every data value. Okay, before we do our examples together so you can see how it works, are there questions on this? I see 3 people who maybe shouldn't be in this class if they're not going to pay attention, and I'm a little frustrated right now. Okay. All right, we're going to do one by hand, one with a calculator. Yeah? By hand, we're doing exactly what I just walked you through, building a table. 3 columns, data value minus the mean, data value minus the mean squared. At some point, I need the mean in order to do those calculations. We calculated that yesterday. For data set A, what was our mean? That was the median. I think it was 6.8. Perfect. Thank you. So in my middle column, I'm going to subtract 6.8 from every data value. So let's copy our data values down. 9, 6, 9, 10, 8, 4, 6, 1, 8. Whew. A little squishy in there, but it'll work. All right. That's just copying. Copy the data values. Next, subtract. Data value minus mean. So x value minus 6.8. I'm going to do it by hand. Please check that I don't make a boo-boo because it's been a long day. So 9 minus 6.8 should be 2.2, assuming I can do math in my head. I see some nodding, yay. 6 minus 6.8 is minus 0.8. I get another 2.2. I get a 3.2, a 1.2. 4 minus 6.8 is negative 1.8, negative 0.8, negative 5.8, and 1.2. This is the 3rd time I've done this today, so I'm pretty sure I did that right, but please check. Yes, it would. Thank you. Thank you. Better. Did I miss anything else? Okay, good. Thank you for catching that. All right, next step. I cannot do it in my head. Next step, we're going to square those numbers, multiply them by themselves. Yeah? If you're doing it on your calculator and you're using the squared button, parentheses around the negative values. Yeah? All of these should be positive. So let's see how fast I can type. 2.2 squared. I get 4.84 While I am answering the phone, please continue that squaring. Jala speaking. I'm all right. How are you? Yeah. Okay, thank you. I will. Chris, you need to go to the finance office. You can do it right now or you can do it at the end of class. Okay, has anybody else started doing that squaring? Yes. Who said yes? Was that? Thank you, Jennifer. What'd you get for the next one? 0.64, and then another 4.84, and then what? You're still doing it. Anybody else got those? 10.24. 1.44. 84.
0.64. 33.64 and 1.44.
1.44, 73? Seems too big.
I said 33.
Oh, okay, that makes more sense. 33.64? Perfect. That makes more sense because I was about to say 6 times 6 is 36. This should be a little less. Yeah, perfect. Good. That was tedious. The rest of this is quick. I know that my formula is the square root of the sum of that last column, this thing here. I'm going to add it up, and I'm going to put it in the top of my fraction, divided by n minus 1. So off to the left, we'll start with the easy one. How many data values do I have? 9. Very good. So n minus 1 is going to be 8. Bottom of my fraction becomes 8. For the sum, we're going to add down that column. And please check me if I'm wrong. I think it's 65.56. And I see some nodding. Good. So this sum is 65.56. That becomes the top of this fraction. And on our calculator, we type that in. Square root of 65.56 divided by 8. And I get 2.9 rounded. 2.86 something, 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 something. I see some nodding. Good. Good. I am assuming most of you are healthy, sane individuals who don't enjoy doing that, so you never have to do that by hand again unless you want to. What we're going to do is review how to do it with a calculator because we didn't have our calculators yesterday. If you do not have your calculator with you, please sit next to somebody who has one so you can follow along. All right. For B, we're going to find it with a calculator. What button do I push to get to my functions on the calculator? Stat. Perfect. It's your new best friend. Stat. And then we're going to press Enter to get to that list menu. So stat, enter, and you should see a big spreadsheet with L1, L2, L3, L4. I want you to put data set B into L1. I'm going to give you just a minute to do that. Data set B should go into list number 1. Data value, enter. Data value, enter, all the way down. So second mode always takes you home, and you're going to press stat, and then enter. Good, and then type the data values. Number, enter, number, enter, number, enter. So stat, up here in the middle. Good, and then enter. And then you're going to type those numbers into the list. 5, enter, 1, enter. Good. Second, quit. So stat first, and then enter. There we go. And then the numbers. Number, enter, number, enter. Good. Yep. Anytime you want to get out of anything, second mode.
Okay.
Good. And then stat.
This one?
Stat.
Oh, I didn't know.
And then enter.
She's a little blind.
No judgment. No judgment. And then the numbers in list B. So 5, enter, 1, enter. Good. Good. Did you manage to, is yours not turning on?
No, it's dead.
Like dead we didn't charge it, or dead like broken dead?
Dead like I did.
Okay. So take it home tonight so it's ready for tomorrow. Yeah.
Oh, yeah, we have it right here.
Perfect. Good. Good, good, good. 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 Okay. Squeeze back up front. So most of us have data in that list. So you're going to need to take it to the textbook room after school today and let them know it's just not holding a charge. Yeah. No second. No second. Just straight to stat. Yep. And then enter. And then start typing those numbers. 5, enter. 1, enter. Yeah. Good. All right. Once your data is in a list, I want to do a calculation. I'm going to press stat again. It's going to take you back to that same place you started with. We don't want to edit anything. We want to calculate something. So you're going to press sideways so that you are on the calc menu. C-A-L-C, calc. And it should show you a whole new menu that looked different than that first menu. It should start with 1var stats. If you are in the right spot, you should see 1var stats at the top of your screen. You are going to press enter because that's what we want to do, some one variable statistics. I see shaking my head. Why are we shaking our head? So stat,
Yeah.
and then sideways to where it says calc. And then we want to hit enter because we want 1var stats. There you go. When you hit enter and select 1var stats, your calculator should default to have list 1 as your list item. Yeah, it should say list L1. That's perfect. That's exactly what we want. Go down to calculate and hit enter. Okay, so yours says, when it says go to for an error, hit go to, and you'll notice it's showing you that your 1var stats command is actually asking for 2 data lists, even though you don't have 2 data lists. So we're going to go and we're going to clear that out. And we're going to go back to stat, calc, enter. And notice you have something in your frequency list that shouldn't be there. So we're going to clear it. And then you try it. Okay. If you manage to do that, the very first number you should see is 5.4 something. That's the mean that we found last time. If you scroll down a little bit, you should see S, X, and sigma X. Which one of those do I want to write down? SX, very good. Sample standard deviation. And my calculator is telling me that it is 3.2. 3.2. Those menus, stat enter to put data in, stat calc enter to do 1var stats, we are going to be doing that a whole lot during first semester. Those are going to become your best friend because that does a whole lot of calculations all at once. Yeah? Good. Comparing those two standard deviations, which one do we think is more variable? A or B? B, because B's standard deviation is larger. Very good. If we scroll down a little bit to facts about standard deviation, greater variation comes from larger standard deviation values. The bigger the SX, the more variable the data is. Yeah. Another important fact, standard deviation is always either positive or 0. We should never have a negative standard deviation. We can't take square roots and get negative answers in stats class. We should not be seeing that. Should not be happening. Positive or zero. You will only get 0 as a standard deviation if there is no spread. Meaning on a dot plot, every single data value is in the same place. That would be no variation. That does not happen in reality. You should not be getting 0 standard deviation for any data we use this year. You're not going to see a single graph where everybody had exactly the same answer. The next thing is SX is not resistant. This guy is not a resistant stat. He goes with the mean. They're paired together. They are both not resistant, heavily influenced by outliers. The next thing, I'm going to introduce a new vocab word here. The standard deviation measures average deviation. Deviation is a word in statistics to make statisticians feel smart. Deviation is just our distance from the mean. That was the x minus x bar that we had in our formula. Do I have any future physicists or engineers in the room? I do. So that formula that we had here where we defined it, that averaging process where we had to square and then square root, is very common in fields like physics and statistics or physics and engineering. It is called a root mean square process, RMS, and it pops up anytime you have to deal with things that come in both negatives and positives that tend to cancel. So if you're in physics or engineering, you will see it again. You may see it in other fields, but those two fields I know for sure because I've taught classes for those fields. Yay. Okay, questions about the standard deviation? No. Okay, we're going to start talking about interquartile range, which is our last measure of spread. He's the guy that goes with median. What we don't finish today, we will finish tomorrow. Yeah. All right, so quartiles. We have heard that prefix before, quarter, quart. What does it indicate? 4. Yeah, you need 4 quarters to make $1. So quartiles have something to do with 4. Specifically, quartiles take a list of data and cut it into 4 equal count chunks. 4 chunks, same number of data points in each. So 25% of my data, 25% of my data, 25% of my data, 25% of my data. And I have a question for you. If I want to take something and cut it into 4 pieces, how many cuts do I need to make? 3. Yeah, if I have a line and I want 4 equal chunks, I cut it in half, and then I cut the halves in half. That's 3 dividers. Meaning, even though quartiles imply 4, I only have 3 quartiles. We call it a quartile because of the results from that division, not how many of them there are. 3 quartiles. And as the creative statisticians that we are, we called them the first quartile, the second quartile, and the third quartile. Because we are creative. I don't know about you, but I don't want to have to write those words out every time I want to talk about them. So we are going to use a symbol for quartiles. Q1, Q2, Q3. Q1 is the half of the lower half. Q3 is the half of the upper half. Q2 is the half of the whole data set, also known as the median. Those 2 labels are used interchangeably for the same number. They are the value that cuts the data set exactly in half. And here's the nice part. When you ran 1var stats on your calculator, it spit out those quartiles all the way at the bottom of the screen if you scroll down. You already know how to find them, the same way we find mean and standard deviation. To get the interquartile range from the quartiles, you do Q3 minus Q1. So you run one var stats. It spits out the quartiles. You do Q3 minus Q1. That is your measure of spread. What it is calculating is the width of the middle 50% of your data. Because up here in this picture, here is Q1, here is Q3. I know each chunk is 25%. The distance from Q1 to Q3 is the middle 50. The interquartile range is looking at how wide or narrow the middle 50% of your data is. That's what we're calculating. Slightly more accurate, because unlike the range, which looked at the endpoints, which are susceptible to outliers, quartiles are looking at the middle chunk of data, which has nothing to do with the outliers that are at the edge. So the IQR is resistant in a way that the range is not, because it's only looking at the middle chunk. So we're going to do the example for B, because you should already have the quartiles on your calculator. And then we will finish these notes when I see you tomorrow. So for B, you just ran one var stats on your calculator. If you scroll down, what do you get for Q1? And I heard a 2. So also what I got, what did you get for the median? 5.5, we found that yesterday. What did you get for Q3? 8.5, perfect. I want the interquartile range. I'm going to subtract. So IQR is equal to Q3 minus Q1. 8.5 minus 2 is 6.5. Nice. The calculator does the heavy lifting. It spits out our quartiles. We just got to subtract Q3 minus Q1. Yeah. All right. When I see you tomorrow, we're going to finish the notes, and then we're going to play the degree chain game. Don't forget, Friday you have a quiz. That quiz counts as homework. It's meant to help you gauge where you are with the material. Not punishment. It won't hit your grade hard. Just to help you, let you know where you are. Yeah? You have questions? I'm going to be here after school today and Thursday. Tomorrow is Senior Splash. And I will be helping out because I am the senior class advisor. So hopefully we'll see you there and you can squirt me with water guns.